Hello folks, we're going to be working with Circuit Playground Express, which we'll call CPX. And to get started programming in CPX, you don't actually need to have one. We're going to use an emulator that we can access via any browser. So in order to do that, we're going to go to makecode.adafruit.com, and you should see a page that looks like this. You may not have these working projects that are up here because I've already been using it, but if we click on New Project here, we see an area where we're going to be able to start to do some programming in what's called MakeCode. You'll also see that we're going to be able to fool around with some JavaScript. But first, let's take a look at the Circuit Playground Express itself. So here's a blown up image of it in the simulator. Now, the Circuit Playground Express is made by a company called Adafruit in New York City. Adafruit's a multi-million-dollar firm, and it was founded and it continues to be run by Limor Fried, who started the company in 2005 in her dorm room at MIT. Limor Fried is also known as Lady Ada in honor of the 19th century Ada Lovelace, who is widely regarded as the first computer programmer. By the way, Limor Fried also grew up in Brookline, Massachusetts, just a short distance from the Boston College campus. So what is the CPX, the Circuit Playground Express? Well, it's a computer, but it's loaded with sensors. It's about the size of a Ritz cracker. It's not super powerful like a laptop or a smartphone. It has a tiny brain. It has a tiny amount of memory, but it doesn't need an operating system like Windows or the Macintosh operating system, and it's super cheap. This whole thing is less than $25. Now you might ask, what can it do? Well, I'll bring up another screen to show some of the capabilities that we have. First of all, we talked about that brain that it's got here, and in the way that your computer may have an Intel microprocessor in here, this microcontroller here is the chip that provides the processing power for the Circuit Playground Express. And the flash memory is a small 2 megabyte amount of memory, which is in there, but it'll allow us to run a version of the Python programming language too. There's all sorts of things that this thing can do, and sensors really are where a lot of the power is. Inside this tiny little Ritz cracker of a computer, there's a motion sensor. And in fact, to go back over, if you're taking a look at your Circuit Playground Express, you'll see right here in the middle around this chip, which is the motion center, it says X, Y, and Z. And that means that this device can detect motion across all different axes. So you can tell if it's been tilted in certain ways, flipped over, lifted, or put down. Now, in addition to the motion sensor, we also have down here where the ear is, that's a microphone, so we can detect sound. Up here where there's a little eyeball, that's actually where the light sensor is, where we can detect light. There is a thermometer up here for detecting temperature. There are also two buttons, a left button and a right button. You see that they're labeled A over here and B here too, so we can get some user input. And in fact, these can detect a bunch of different kinds of user input. So for example, a regular press, a long press, the press of both left and right at the same time. In addition to that, there's a slide switch down here, which you can flick to two different positions. Now you see these little copper circles around here. They can do quite a bit. 7 of them are actually what you would call capacitive touch sensors. That means that they can tell when they've been touched. And in fact, not only that, but they can also tell if anything attached to them has been touched, as long as those things can carry an electrical current. And you'd be amazed at the kinds of things that can carry an electrical current. We'll talk more about that later. But they effectively can act as 7 more buttons if you would like. There are a bunch of other things that we have on here as well. So these circles that you see around here are a bunch of multicolored lights. They're sometimes referred to as RGB lights, and in fact, Adafruit uses the term NeoPixel when it refers to those different lights. We can program them, we can change the brightness. There are all sorts of animated patterns that are built into the programming environments that we're going to be using. And to go back, you see that this says IR in and IR out. IR in means infrared in, meaning it can receive an infrared signal, and IR out is it can send an infrared signal. That's the same signal that's used, for example, in most TV remote controls. Now, IR is just a kind of light that we can't see, so it's just beyond red in the spectrum of visible light that you probably learned as Roy G. Biv. The R in Roy G. Biv stands for red, so we can't see anything beyond red. But as long as there is a line of sight between this device and either the sender or receiver, it can pick those signals up. And this is really wonderful because you can use multiple Circuit Playground Expresses together to create games or other kinds of things where you want to send a message and have the other device respond to that message. Now, in addition to that, you see these copper connections on the outside. I said some of them support capacitive touch, but they're also designed specifically so that we can hook things up to them. We can use what are called alligator clips. Sometimes they're called croc clips, but alligator is the more accepted term. They're just these little clips here so we don't have to do any soldering, and we can wire this up to all sorts of other devices. So my students will be using a strip of RGB lights. They'll learn how to animate that using the Circuit Playground Express as the brains, which we'll use to create all sorts of animations for those lights and also change the lights in response to sensor input. We can also use these clips to connect the Circuit Playground Express to things like external motors, they're sometimes called servos, or large screen displays. You can even use these circles to get additional input from more sensors. Say, for example, soil samples to tell if a plant needed to be watered. And you can actually even use a simple nail to act as a server, and we'll learn more about that later. Just a little bit more in our tour of the Circuit Playground Express. Up here you'll see that it says Micro B USB jack. This is actually where you're going to plug in the cable to connect your Circuit Playground Express to your computer. So this is where you'll download any of the programs that you write, and it will also power the Circuit Playground Express when it's connected to the computer. Now, you don't want the Circuit Playground Express to be connected to the computer all the time, so that's why we have down here this thing that has a plus and minus next to it. This is a battery connector, and the standard that it uses is called JST. If you go on the Adafruit site or others, you can see a whole bunch of different kinds of battery packs that support this standard. You can plug it into a AA or a AAA battery. They even have these smaller, lighter, rechargeable li-poly batteries that you can use as well. So great, it does lots of stuff, but how do you get it to do lots of stuff? Well, we're going to program the device, and there are lots of different ways to program it. And when we talk about programming, what we're talking about doing is really setting up a set of instructions that a computer can follow. One of the ways we're going to do this, and the easiest introduction that we're going to have here, is going to be using something called Microsoft MakeCode. And that's where we are right now. This is a version of MakeCode set up for the Adafruit Circuit Playground Express. Now, MakeCode is actually a programming environment that's sometimes called block programming. If you've ever worked with Scratch before, you've worked with this kind of environment where it's just an ability to drag and drop. You can click and see that there are different statements here. You can drag them over, snap them in, and in our simulator here, it'll actually show you what's happening here. So I just dragged over here. We'll learn how to do this in a bit. You don't have to follow along, but I've added an animation which just shows a sort of rainbow effect here. So block programming is a great way to get started because it really prevents some of the errors that could occur if you mistype something, you have a typing error, that kind of thing. Now, in addition to MakeCode, we can also use Microsoft MakeCode to work with the JavaScript programming language. Now, JavaScript is just a programming language in the way that different spoken languages are different ways for people to communicate. So JavaScript is actually really popular for websites, but we can also use that in MakeCode as well, and you can go back and forth between the two. Now, in addition to that, the folks at Adafruit have put together a programming language called CircuitPython, and CircuitPython is a version of the very popular Python programming language that we can use to program the Circuit Playground Express. And if you've never heard of Python before, it's very popular. It's typically the first programming language that most computer science programs in college use. It is also very popular with data analytics, so it's really useful from a business context. So it's yet another way that we can set up a list of instructions and use those to get the Circuit Playground Express to do whatever we want it to. Now, in addition to the MakeCode blocks and JavaScript and CircuitPython, the Circuit Playground Express also supports programming that is used on the popular Arduino standard of hardware devices. Now, Arduinos are also these small computing platforms, an open standard. Many different devices support the kind of programming that you would do on any Arduino. And in fact, the free environment that is set up to program these kinds of devices uses a variant of the C++ programming language. Now, C++ is really old. It's not necessarily a good first language to use, but what's good about this is lots of people have already written really cool code and made it available online. So oftentimes, if you want your device to do something, you can simply download somebody else's code, use it straight up, or make some small modifications to it, even without knowing a whole lot about C++ programming. So that makes this device extremely versatile, as well as having all of these great things that we can use in order to experiment with some programming and do our own stuff from scratch as well. Now, one other thing, you might take a look at this and say, oh, well, I've heard of Arduino, and this does support the Arduino standards here, so you could say it's kind of an Arduino, although it's not put out by the Arduino company. But there's also something called the Raspberry Pi. You might say, hey, is this a Raspberry Pi? And the answer is it's not. So the Circuit Playground Express and Arduinos are all considered to be microcontrollers. And microcontrollers are these stripped down computers. They only run one program at a time. So these are really good if you want to do something like control a strip of lights or monitor the soil of your plants, or listen and respond to a sound or a particular temperature. Now, if you want to do something more complex, let's say you've got a more complex robot that might have some computer vision and collision detection, and it's constantly listening to respond to sounds. Well, that's when you might use something like a Raspberry Pi. And what a Raspberry Pi is it's a full-blown computer. Now, it's a really cheap computer, but on that computer, you also need an operating system. So it's usually something like Linux, or it even runs variants of Windows. The Circuit Playground Express, Arduino, and other kinds of microcontrollers, those guys don't need an operating system. So for the basic tasks we're going to be using right now, Arduino is a really great choice. It's super cheap. When you get into some things that are a little bit more complex, you can also go and try out this Raspberry Pi stuff. Now, one last thing that I want to mention too, the brain of our Circuit Playground Express, it uses a microprocessor called the ATSAM D21. Now, that sounds really, really geeky, but it's based on what my students are learning as an ARM processor, a processor that uses the ARM standard. So it's not manufactured by the ARM company, but it is it actually uses some logic which is licensed from the ARM company. Now, ARM, as my students learn, is actually a standard which is used in almost all smartphones that are out there, just in the way that the Intel standard is used in almost all laptops and personal computers out there. Now, this isn't as powerful as your smartphone, but it does show, hey, the standard for low power computing, which is why ARM has taken off in cell phones, has even gone down to this device. My students also learn that technology is getting faster and cheaper. So whereas we can get a few things done on the Circuit Playground Express, and actually quite a bit done, this is only going to get more powerful and less expensive over time. You'll likely see more sensors baked in or more sensors combined with chips. So this is a great platform for us to begin to experiment, to see hands-on some important management principles we're learning about, and you'll also get some programming and even a little bit of engineering in here too. So this is our ride. Let's get going.